Hello guys. Here we have a Lenovo. This is G500, David, or G50. Okay guys, this is a G50, Lenovo G50. Great. My gloves there. Okay, never mind. It's not turning on at all. Anyway, you know what to do when we are dealing with a dead machine, right? Step number one, you do a physical inspection. Let's go ahead. Let's do a physical inspection. I think it's best if we remove this machine out of the chassis. Let's go ahead. All right, I have the screwdriver. So what you do, you remove screws everywhere, and then remove those cables. Okay, both cables are out. Remove the speakers, remove the fan, then you remove an LVDS cable. Okay, one more time, one more thing. We need a charging port. And we need a fan. I have to remove the fan from the chassis. Okay, all right, here we go. Let's go ahead. Let's repair this. So what you do, you connect your port here. After that, let's do a physical inspection. I didn't see this side. I don't see any damages. Okay. So now, what do we do? Okay, what do we do? Let's check some steps there. Check your 19 volts. Let's go ahead. Let's check our 19 volts. So what I'm gonna do, I'm gonna connect. All right. Okay, you can see that someone did try to solder this. Let's confirm if it was done proper or not. Oops, I disconnected ground by mistake. Okay. Okay, seems fine. Never mind that ground. It's gonna work. Our PC will work with one ground. It doesn't matter. So you take a DC bench power supply, and then you set it to a 19 volt. Okay, connect ground and then positive. Okay, the machine has been turned on, but nothing. Okay, no power. And then let's check the 19 volts. Okay, it says that check the 19 volts. Let's go ahead. Let's check for a 19 volts. One probe to ground. Then there's a fuse there. We do have 19 volts. Okay. This is the first MOSFET. Okay, so this is how it's gonna be. You will have the first MOSFET, and then you will have the second MOSFET. After the second MOSFET, you will have this, a current sensor. So let's go back. Okay, you check the first MOSFET, power. After a second MOSFET, there's 19. Obvious here on the second MOSFET, on the input side of the second MOSFET, you will have 19, obvious. What about the output? On the output, we have 1 volt. Okay, on the output of the second MOSFET, we have 1 volt. Let me show you again on the MOSFET. Here on the first MOSFET, we do have the 19 volts on the input and the output, and then on the second MOSFET, we do have power on the input, obvious. And then on the output, we have 0 volt. We have 1 volt. Even here on the current sensor, there's 0 volt, 1 volt. Yes, I made a mistake there when I was writing current sensor, but you'll get used to it, guys. I'm so lazy to change that spelling, but anyway, that's not important at all. Let me show you how our first and second MOSFET looks like in real life on that board, and again we can have a look on the schematic. Let's check the schematic. Okay, these are the schematic. So what you do there, you type the board number. The board number, it's A3. Okay, let me type A362. Then you press enter. There it is. Once you have the schematic, you type charger there. You look for charger. You search for charger. And then press enter. Press enter again. Press enter again. I want to show you the first and the second MOSFETs, and yeah, boy, I'm gonna show you everything. Okay, Sarah, here we go. Alright, this is a charging chip. Okay, there's our first MOSFET and the second MOSFET, along with a current sensor. Now it's gonna make more sense. You'll be able to see the current sensor. PR301, this is the current sensor, and then PQ302 is the second MOSFET, and the first MOSFET is it's PQ301, our first MOSFET. PQ302 is our second MOSFET. So there on the first MOSFET, on PQ301, we do have 19 volts on both sides. But on the second MOSFET, we have the 19 volts on the input side, but on the output side, we have nothing. We have like 1 point something volts, of which is not enough because we need 19 volts there. And then, yeah. So let me show you these two MOSFETs and the current sensor. This is how they're gonna be right now. Let's have a look on the real life. Let's have a look. Okay, there we go. Here we go. Here is our positive. This is our 19 volts. This is our 19 volts. And remember very well, we do have the 19 volts on this fuse. This is a fuse. PF is power fuse 101. We do have the 19 volts. PLs, they act as fuse as well, and we do have 19 volts. Where is PQ301? There we go. PQ301, we have the 19 volts on both sides. And then on the second MOSFET, where's the second MOSFET? PQ302. Okay, hope you can see the power flows here like this, comes here on PQ302. We do have the 19 volts here, but here we have 1 volt. And this is PR301, the current sense. It's always like this, two MOSFETs and the current sense. There we go. This is the current sense, and it's always R010. I think even here, let's check here. R010. It's always. So let's go ahead. So now what we're gonna do, we'll have to check for shorts. Let's check for shorts, but I don't think there's a short there. I'm gonna do anyway. Turn your multimeter into a continuity mode, and then one probe to ground. No shorts. Okay, let's check something. All right, let me repeat this. Here we don't jump MOSFETs. I don't recommend people to jump MOSFETs. Okay, the problem here, the first MOSFET is shorted. There's a short on the first MOSFET, meaning it's shorted. If there's a short on the first MOSFET, the second MOSFET won't allow power to go through, because the BQ, of which I believe is this chip, the charging chip, communicates with these two chips through gates pins. Okay, so if there's a short here, BQ, the charging chip, won't allow the second MOSFET to allow power to pass. Even if you breach this, you jump this using a wire or whatsoever, the laptop won't charge, and again you'll end up killing the charging chip. It's not recommended at all. We have to replace what? The second MOSFET. There's a short here on the second MOSFET. I mean, there's a short on the first MOSFET, sorry. So let's go ahead. All right, PQ301 is shorted. Okay, one more thing before you remove this, we have to know the type of MOSFET they were using there, whether it's P or N. You can do that by checking the second MOSFET. Let's check the second MOSFET. 44H3. It means they were using a P channel MOSFET. And again, if you're not sure or you are doubting, it's easy. You can do this. Open the schematic. On the schematic, you zoom in. After zooming in, you have to highlight this as it is, and then say copy. Go to your browser, open a new tab, and then paste and search. There we go. You say download, open. Okay, it says 30 volts P channel MOSFET. That's a P channel MOSFET, as I told you. So there it is. It's a P channel MOSFET. They were not using an N channel MOSFET, but they were using P channel MOSFET. So let's go ahead. Let's replace it. All right, guys. So now, what do I have? I have a donor board. So I'm gonna take out this. Okay, this is out. Okay. All right. Okay. So now, guys, what do we do? Let's check. Okay. Let's check the MOSFET we got, if it's working or not. Okay, no reading. So you reverse the probes. Okay, hope you saw. Okay, why it didn't read on one side is because the MOSFET have the diode inside. There is a diode inside the MOSFET that pushes power one direction. Yeah, one way. So let's go ahead. Let's replace this guy. Okay. That's what I'm trying to check. Okay, it means we have to rotate the MOSFET. Okay. One more thing, check here. There's a small dot there. That small dot should align with this white dot on the board. So once you are done, you have to clean. I prefer people cleaning their board. Clean your board, clean your board, clean your board. Clean your board. Once you are done, you have to clean your motherboard. Clean it nicely. As you can see, 4407A, that's a P channel MOSFET. I'm pretty sure. You can tell by, you know, those four digits, the last 4 digits, the last number there. You check whether it's an even number or an odd number. If it is an odd number, it means it's a P channel MOSFET. But if it is an even number, it means it is an N channel MOSFET. So this is clean, neat, done. All right. It is done. Looks nice to me. There we go. Looks nice and easy. All right. So now, what do we do? Okay, let's put back everything.
It's dangerous, you can fall down.
That's okay. So now, before we connect the power, let's check. I knocked off a capacitor by mistake. Let's check for short. No short. Let's reverse the probes. Okay, good. Let's check the second one. Let's reverse the probes. Good. Let's check for short. No short. Let's check the 3.3 volts and the 5 volts. No short. No short. The 3.3 and the 5 volts are sharp. It means there's no short. This board is working, you'll see. You can leave it aside. We don't need that cap. So now let's connect the fan. Why I'm connecting the fan? I want you to see the fan spinning. I'm so confident that this board 100% working. Please stop jumping the MOSFET, guys. I don't understand why people jump MOSFET. Stop jumping the MOSFET. It's wrong. Way far wrong. Imagine repairing laptops that won't even charge, because obviously they won't even charge the battery, and you'll end up lying to clients just because you can't do a proper job. So what you do, turn on the power supply, and it's taking power. The fan is spinning. Ta-da! You saw a fan spin, right? Taking 200 milliamps. I believe it's because there is no, even the light, there's a light here, you can see a light, there's a light right there. Okay, so now what we do, remove this, we take the string, this is how you do it. Oh shit, now you can see me on the screen. That's bad, nah? And we need a RAM. Okay, let me check my spare RAM somewhere. Here I have my spare RAM. Connect the RAM. They're connecting the RAM. Now we have to connect the string. Where do we connect the string?
Near the charging port.
Okay, it's here near the charging port. Thank you, brother. So put it up. Yes, push it with force there, and then you turn it around. Okay, I believe you'll be able to see a display. Okay, the machine is off. Okay, that's bad because I didn't connect the power. Let's connect this. Turning on again. Okay, this is not a good sign. You know I'm saying you know why I'm saying this is not a good sign. It's because no one pressed the power button and the machine turned on by itself. That's not a good sign at all. No one pressed the power button, but it's turned on by itself. Let's check the power button. 3.3 is there. 3.3 is there. 4 volts. 3.3. Okay. Okay, it doesn't turn off. Okay, it's now off. Let's turn it on. It's now on, but it's still taking 200 milliamps. We need a RAM, a working RAM. Okay, I have a RAM of which I believe it's working. So let's use this RAM. I wanna be sure of everything. And again, what we can do, we can reset this PC. Okay, now we have the 19 volts all over the board, and that's why we have the 3.3 on the power buttons, because the 19 volts is going all over the board. Now I'm trying to reset it. Okay, I think that's enough. Let's turn it on. Now checking 40, 38, 40, there's a change, 33. Ta-da! Okay, now you can see with a working RAM, we have a display. Okay, it went off. I think it's resetting. Let's wait for it. You saw a Lenovo there. And then ta-da! Here we are. Okay. I'm not sure why it's doing this, but it's working. Let me try to solder thing proper. Okay, anyway guys, this is it. I'm gonna check this tiny problem, but I'm happy because it's now turning on, and I'm gonna try to use a proper working RAM to fix this. But it's stable for sure, I know. Sharp. Oh, wait, before I go, don't forget to press the subscribe button.